Hello, everybody. This is Mr. Merriback. As you might have noticed, I'm not there, but I will do this recording, and hopefully that'll help you with the lesson. I will be hopefully back tomorrow. So today we'll be talking about internal and external angles of a triangle. It's something you did before, probably in grade 8. And before we begin, I'm just going to describe what an angle is. So an angle is a space between two lines that either intersect or that touch or meet at one point. So in this case, this would be our angle here, this measurement here. And we usually measure it in degrees. There are other units, but for us, it's going to be only in degrees. So the first thing that we're going to do, and you're going to have this handout, we're going to look at 3 different types of triangles. So the equilateral, isosceles, and scalene. Equilateral is the first one, and how it's described is that it has the same sides, same length. So this shows us that all 3 sides are the same, and then as a result, all 3 angles are the same. And in fact, all 3 angles are actually 60 degrees. So this is degrees. This is also 60 degrees. And this one is also 60 degrees. So that is what makes equilateral triangle an equilateral triangle. Now the next one is isosceles. The unique thing about isosceles triangle is that it has only 2 sides equal. So this one and this one. So if it was 10 centimeters here, it would be 10 centimeters on the other side as well. Now, when you have a situation like this, what happens is that the angles opposite from those sides, so this angle and this angle, are also equal. So if this was maybe 30 degrees, then this one's also going to be 30 degrees. So they have to be the same if the opposite 2 sides are the same. So that is the second type of triangle. And the next one is scalene. The unique thing about scalene triangle is that nothing is shared. So all 3 sides are different lengths and all 3 angles are different lengths. So we're going to encounter all of these triangles in the future, and you just have to remember what's unique to each type. All right, so our next part is about internal angles of a triangle. And before we begin, we're just going to label this triangle that we have here. So usually we would put A, B, C, and we have angles. So angle A, angle B, and angle C. And the angle sum of all these 3 angles, so the angles inside the triangle, is 180 degrees. So if I add them up, angle A plus angle B plus angle C, I will get 180 degrees. And this works for every triangle. It doesn't matter what type it is. It doesn't matter what the lengths of sides are. All those 3 angles always add up to 180 degrees. That is the rule. And this rule we're going to use to calculate missing angles in triangles. So if we look at example A, we have 3 angles. So there's 1, there's 2, and there's 3. And all these 3 angles, if we add them up, they should add up to 180. However, in this case, we have 2 of the angles, which is 119 degrees and 34 degrees, but we're missing this last one, which is B. So if I write it like our statement up here, if I add up all the angles, they should add up to 180 degrees. So if I write 119 plus 34 plus B, they should be equal to 180 degrees. Now this looks like an equation, and it is an equation, so we can solve it. we're going to calculate what B really is. Before we begin, we can add up these two values. And 119 plus 24 is going to be, so that turns out to be 153 degrees plus B equals 180. And we do the same thing we did with equations. We're going to subtract 153, subtract 153 here. And it turns out that B is going to be equal to 180 minus 153, and that is 27 degrees. And that's how much this angle is. There we go. And that is the process. Usually we will have two angles, and then we can calculate a third one. Now, there is another way. You don't have to solve it as an equation, and that's how we're going to do it in the next one. So instead of writing this as a sum of three angles, so we're not going to write 26 plus 45 plus B equals 180. We can write it right away like this. So B is equal to 180 minus 26 minus 45. And that can also be our final answer. And that is 109. There we go. So whichever way you use, just show your steps and you should be fine. So our next example, it says, can a triangle be formed that has the following angles? So we are given three angles. We have an example in A, and we have three angles in B. And we have to check if a combination of these three angles is actually possible. And how we do that is we already know that they're supposed to add up to 180. So all we have to do is check them by adding all of them. So 40 plus 60 plus 75. And we're going to add them up and see if they add up to 180. 40 plus 60 plus 75 adds up to 175. Now, because this is not equal to 180, it's 5 degrees short, that means that by using these three angles, we cannot actually make a triangle. It's not good enough. So this is a no. You can, at this point, pause the video and try B and fill it in and see if you can actually make a triangle out of 14 degrees, 52 degrees, and 118. Once you're done, you can unpause and move on. I'm just going to move on to the next page. The last example, it is talking about isosceles triangle. And it says that isosceles triangle has two sides and two angles equal. So how we show that, we can actually sketch it. And it doesn't have to be anything too perfect. So maybe something like this. And how we show that it's an isosceles triangle is we label it like this. So that means two sides are equal. That means the angles are equal. So A says if the two equal angles are 40, so these two angles should be 40 because they're opposite from the equal sides. We don't know what the sides are, but it doesn't really matter. We know that the two angles are equal, so two angles at the bottom are 40. The question is, what is the remaining angle? So the remaining angle is this one here, and we call it A, let's say. And what we have here is just another triangle. We have two angles, and we're looking for a third one. Once again, all angles in a triangle add up to 180. So we can calculate A simply by subtracting 180 minus 40 and minus the second 40. And we just put it in the calculator. And we get 100. it is supposed to be 100. There we go, 100 degrees. And that would be our answer. So the last remaining angle is 100 degrees. That was it. A. B, we're going to look at it, and it says if the third angle is 92 degrees, what are the equal angles? So this is a very similar question, but it's kind of opposite. So I can still sketch an example of a triangle, something like this. And I can say that these two are equal. And what I have now is this angle here up top is 92 degrees. Now I'm missing two angles. So these two angles at the bottom, but they're going to be the same angles. So we go back to the rule about internal angles of a triangle. They add up to 180 degrees. So if I take away 180, so if I take away 92 from 180, what I get is 88. So 88 degrees. Now this 88 degrees represents two angles at the bottom. Well, not just one angle, but represents two of these. But we know that those two angles are the same. So how we can get the individual angles is that we can take 88 and divide them in half so that we can get two of the same angles, which turns out to be 44 degrees. So that means that this one is 44 and this one is 44. Now, if we're not sure that's correct, we can add up these three angles and see if we get 180. So if I check by doing 92 plus 44, another 44, I should get 180 if we did everything right. 92 plus 44 plus 44, and we do get 180. So you can always check at the end if you did the question correctly. And that is it. The most important message here is that you remember that all angles, so angle A, angle B plus angle C, add up to 180 degrees in a triangle. And they don't have to be angle A, B, C. You might see X, Y, Z, or any other letters, but they add up to 180 degrees. And from there, you can find usually the missing angle or angles if it's an isosceles triangle like this. All right, so that is it for internal angles of a triangle. Now we're going to look at exterior angles of a triangle. So exterior means outside. So interior, internal means inside the triangle. So we took care of that. Now what we're going to look at, well, before we actually talk about internal or external angles, I'm just going to draw a straight line. And a straight line, if you're not aware, if I measure the space from here all the way to here, it is 180 degrees. And that's going to be very useful for us because we're going to use that trick to calculate many different angles. So whenever you have a straight line, from one side to the other is 180 degrees. If you have a perpendicular, so something like this, what you have, the angle measured from here to here, oops, I'm using the wrong thing. There we go. So from here to here is 90 degrees. 90 degrees. Also another useful thing, but 180 degrees, a straight line like this, 180 degrees will be very useful. So here's an example. So we're looking at example A. What we have here is we have this triangle. So this kind of ABC triangle. And inside we have two angles. Now we also have this extension line. And what this line represents it's an extension line that creates this external angle. So because it's an outside angle, it's not inside the triangle, this angle here is an external angle. And how we can calculate it is we can calculate it by doing a two-step process. So first thing that we can do by using these two angles is we can actually find this third internal angle here. So we're going to use our internal angles over triangle rule, and angle A, we're going to calculate by taking away 74 and 44 from 180. Or, there we go, 180 minus 4 minus 54. That turns out to be 62. There we go. So angle A. Now, remember what I said about a straight line. If I look, I'm going to use a red one. I'm looking at this straight line here. I'm just focusing on that part. And what I said earlier is that if I have a straight line, this angle from one side to the other is 180 degrees. And what I know is that this little part here is 62. I just calculated it, right? So this is 62. And I can use that to calculate the external angle. And how I do that is that I subtract 62 from 180. And that turns out to be 180. So what that means is that this outside angle is 180. And that's it. We found our external angle. So that's one example. Now there's another. And there's also a shortcut, which I think will be mentioned on the next page. But we might as well talk about it now. So here's the shortcut. Whenever you have two angles inside a triangle, such as this, we have angle F and we have angle E, there's a rule about external angles that we can actually define. So what the rule says that if I add these two angles, so angle F plus angle E, it gives me that external angle. External angle. Now, the external angle, this only works if the two angles that I have are on the opposite side of the triangle. So it wouldn't work if I have angle G. If I had angle G, then I can just do the straight line and do 180 minus that angle. But in this case, if I have the opposite two angles, all I have to do is add them. So in this case, I'm going to take 79 degrees plus 32 degrees and add them up. And that turns out to be 111. And that 111 is this angle here. And that's it. It's a very quick shortcut. If you don't remember this shortcut, you can still find angle G by using the triangle. Sum of three angles in a triangle add up to 180. So you can find the angle G, and then you can use a straight line to find the external angle. So all of those work, whichever one you prefer. This one is just a shortcut, and I think on the next page, there we go. It's called external angle theorem, or EAT, or EAT. And that's it. Now, you can apply this shortcut, or you can go through the longer way. It's still going to work. It's just you're going to do a few more calculations. So in this example one, just focusing here, we have a triangle, we have an external angle, and the external angle theorem says that this angle here, the angle F, and angle G, they add up to give you the external angle, which is 135 degrees. So if I wanted to find angle F, all I have to do is take away 20 on 135. 20, 25. There you go, 20. There we go. That is 115. And that's it. That is the external angle theorem. And we don't have to show any more than that. It's pretty straightforward. The next one, example 2. Very similar question. We have angle D, and we have angle C, and then we have the external angle, 145. So the external angle theorem, or EAP, says that if we add angle C plus angle D, we should get 145. So really, if I just want to find angle C, I just have to subtract 145 minus 110, which is the angle D that we have. And gives me 35 degrees. And that is it. Very quick. There we go. I forgot to mention you will definitely need a calculator for this. It speeds up things, and it just makes it easier not to make mistakes. So another triangle, example 3. This is a pretty straightforward one because we have the two external angles. Sorry, two internal angles. So we have angle E and angle F. If we add them to get our external angle. So in this case, we have 40 plus 60, and we will get 100 degrees. And that is this external angle here. And the last one is number 4. Number 4 is, I think it's almost the same as the first one. So we're missing an angle inside. We have one of the angles inside, which is 20. And we have the external angle, which is 100 in this case. So if I want to find angle U, I will subtract 20 from 100, and I will get 80. And that is my angle U in here. And you can try number 5. It's very similar to this question up here. You can pause the video and then try it out. Now the last one, we're going to look at how to calculate all outside angles. So in this case, we have all internal angles. So 75, 70, 85, and 25. And we're going to add them up. Well, if we add them up, we're going to get 180 degrees inside. But now we're going to see if we can calculate all the external angles. So how this is going to work is we're going to use that trusty rule about straight lines. So if I have a straight line, this is my straight line here. This full rotation around is going to be 180 degrees. So if I want to find this angle in here, all I have to do is take away 70 from 180, and that's going to give me that external angle. So in this case, that turns out to be 110. And then I'm going to do the same thing here. So I have another straight line. This angle is 180 now. So if I want to calculate this external angle, it will be another 180 minus 25. So 180 minus 25 gives me 155. And then we're going to do the last one. So there's another straight line. In this case, we're going to do 180, which represents a straight line, minus 85. And that will be 95. There we go. So we have 3 angles. We have 110, 115, and 95. If we wanted to look into some of these external angles, so if we add them up, we can see what external angles add up to. We haven't actually talked about that. So if we take 95 degrees plus 110 degrees plus 155 degrees, let's see what we get 360 degrees. And this is going to be the same again for all triangles. All external angles, outside angles, if you add them up, so three outside angles, they will always add up to 360 degrees. So inside ones add up to 180, inside angles, 180, outside add up to 360. And that's kind of another rule that we can use. You can try the last example too. And then after that, there are some practice questions in your workbook that you can work on. If you have any questions, maybe the supply teacher can help you. If not, I can go over this once again when I come back. And that is it. See you soon.